In this video, we're going to review how to find the surface area of a cylinder, and the formula is highlighted here in yellow in the middle. And essentially, we're going to be trying to cover up all of the faces of a 3D cylinder. On your formula sheet, which is the first part of your packet, we're exploring this right here. Again, in elementary school, you already did these 2D shapes. Hopefully, you've already watched a video for surface area on the rectangular prism. And now this video is for surface area of our cylinder. What we're going to be doing is covering up this bottom circle, which is the same as this top circle. So we're going to have the pi r squared from a circle, and we're going to double it for the top as well. And then I'm also going to explain how to cover up this weird curvy part. All right. Now, I also want to point out that we are going to need for this video some stuff from the 2D circle unit. I'm going to be referring to the circumference formula, and I'm going to be referring to the area formula. So real quick, here's a brief review. For circumference, it's the distance around a shape, so I'm tracing that here in yellow, so the distance around our shape. And then to find the circumference, again, that distance around in yellow, it's 2 times 3.14 times the radius. So you'll probably remember that the radius here is half of the diameter. And if I wanted to shade this area in and find the area of this circle, I'm going to do pi times the radius squared. So if in our picture here, the radius happened to be, let's say the radius was a 3, that makes the diameter 6. And in the formula, we would do 3.14, and the radius is 3. That's what's going to get squared. So this would be a 9, and then times 3.14, and that would be our total area of the circle. You can see right here on your formula sheet that we are using 3.14 for pi, and now I'm going to explain how this formula works. What we're going to look at here is I've got a cylinder, and if I want to cover up the top and the bottom, I'm going to use the area formula for a circle, which is pi r squared. Now right here is the circumference formula, and we're actually going to be needing a equals pi r squared if we want to shade in this region, okay? So the bottom part would be pi r squared, and so I can use pi r squared to cover up the bottom of my cylinder, and I'm going to double it because I want to cover up the top and the bottom. So in the surface area formula, that's where we get the 2 pi r squared from. Pi r squared is one of my bases, and because I've got a top and a bottom, I'm doubling it, and that's why there's a 2 with the pi r squared. All right, now with this cylinder here, imagine we wanted to cover up the outer part, which kind of like a label of a soup can, you can see this weird curvy part. The shape that covers up a cylinder actually is this rectangle here. So all I've done is taken this curvy part and flattened it out right here, and this would be the sheet of paper that would go to cover up this round part. Now to find area of this rectangle, again, we're trying to cover this thing up, so area of the bottom and then area of the curvy part. To find area of this rectangle, it would be this length times this width. So you've got your yellow length times the red width would be the area. Now the thing that stinks though is I don't know what the length of this rectangle would be. The only thing I know is that it is as long as this cylinder is around. So the circumference of my cylinder tells me how long that piece of paper would be that's going to cover it up. So the distance around is the length here, and that's the circumference formula, and that's why you see 2 pi r h right here. Now, the height of the cylinder is going to be the width that you need right here in red. So the height becomes the width. So to find the area of this thing, if it's length times width, it's this 2 pi r times h. And that's the second part of your formula that you see on your formula sheets. So once again, this is going to cover up the top and the bottom. And this is going to cover up the weird curvy side. But that side as a sheet of paper would be a rectangle. So now in your notes, you can just follow along with me. What do prisms and cylinders have in common? So the prisms back on your formula sheet were this thing, and what they have in common is that they have a top and a bottom. So when you find the area of this base down here, you doubled it to find the area of the top. That's this part right here in red. And this also has it in common. You're going to find the area of this circular bottom and then double it because there's a top. And so there's the 2 pi r squared. All right, what is the difference then between a cylinder and a prism? Well, for prisms, the bottom is a polygon, and we've already had our polygons unit where we've talked about triangles and we've talked about quadrilaterals, whether they were parallelograms or trapezoids and things like that. So you could have a bottom that's a polygon and give it height. Now you've got a prism. Or you can have a bottom that's a circle and give it height, and then you've created something like this, which is your cylinder. Okay? All right, so because of this property of cylinders, we simply can't add up the area of faces. What I mean by that is because the bottom's a circle, that means that this face is this weird curvy part, and that's why we can't just say, okay, we're going to just add up the area of a bunch of different rectangles, kind of like we did in our last video where we found the area of a bunch of different rectangles and then added them up. So back in our packet now, what we're going to use then is this formula, which is the 2 pi r squared. That is the two circles. That makes sense. And then we already reviewed the 2 pi r h and where that comes from. In this formula, r represents the radius, of course, and h represents the height, of course. And if I ask you ever, where does the 2 pi r squared come from? It comes from the fact that there are two circles to cover. We have a bottom and a top, so the 2 pi r squared is the top and the bottom. If I ask you about the 2 pi r h, that is the length times the width for the rectangle. And friendly reminder that the length is just the 2 pi r, and then the height would be the width. And we reviewed that right here. You've got the 2 pi r, that's the length, and then the width would be the height. And again, the length is the distance around the cylinder, which is its circumference. That would be how long this rectangle is. All right, sweet. So now let's just see it in action. I'm going to work you guys through this example and just show you how to use the formula. One big thing to be careful about is that you'll notice in this picture, the 8 that I've given you is actually representing the diameter. So if the diameter is 8, then the radius is a 4, and that's what number you want to plug in right here for r, and then right here for r. So we've got 2 times 3.14. The radius in this picture would be a 4, and that's going to get squared. And then we have, for the rectangular part of it, it'd be the 2 times pi. The radius is still a 4, and you'll notice here the height is 16. Now we need to use PEMDAS to simplify, and we're going to be really careful here. The 4 squared is what comes first, and that's where I get the 16. Then you have your calculator to do 16 times 3.14 times 2, and that's where I got the 100.48. Now, friendly reminder that the 100.48, that's just covering up this circular bottom and this circular bottom. So we've taken care of the green circular faces, and now we need to take care of this weird curvy part that, again, if I were to unfold that, it would be a long rectangle that goes around this thing, okay? So you've got 2 times pi, the radius is 4, and then times 16. So all I did was the 4 times the 16, the radius times the height, and got 64. But in your calculator, you really can do this times this times this times this. You can do it all at the same time, and you're going to get 401.92. So if this were a soup can, the label of the soup can would be 401.92. But it's not a word problem. We're not dealing with a real life scenario. So if I was to try to cover up this entire cylinder, I've got the weird curvy part, the rectangular face right here, and then I've got the top and the bottom. And when you add them up, we get the 502.4 square inches. Now, friendly reminder that even though this looks like inches squared, we say square inches. Now, at this point in the video, you have the option to pause and try the 2 down below on your own. Or you can let the video keep playing and watch me model them. But at this point, make your decision, and I'm going to scroll down now to work out the 2 practice problems. All right, so I'm on the first practice problem, and you can see here that we're told that A, all the way across, is 5 inches. We're also told that B has a height of 4 inches. So if the all the way across measurement is 5, the diameter is 5, we're going to use 2.5 here for the radius. All right. Now in our formula, we've got 2 pi r squared plus 2 pi r h. So all you've got to do is plug in the numbers. So we've got 2 times pi, and our radius would be 2.5, and that's going to get squared. And then we have 2 times pi, the radius once again, and then the height of this whole thing is a 4. Now we got to be careful with PEMDAS. First, we're going to do 2.5 times 2.5 in our calculators, and that's where I get this 6.25. Now we're ready to multiply by 3.14 by 2. Now I am going to pull up the calculator and show you, you have a couple of different options here for your order. The first thing that I just did was 2.5 times 2.5, so I squared that. Now I'm ready to do times 3.14. Now I'm ready to do times 2. So I'm going to get the 39.25 here in blue. Now you could go from left to right, and remember that you've got 2 times 3.14. But if the 2.5 is what's getting squared, then you need to do times 2.5 times 2.5. All right? So we're still getting the 39.25. You're going to get it wrong if you do 2 times pi times 2.5 and then try to hit the squared. So if you do 2 times pi and then times 2.5, now if you hit squared, it's going to be a way bigger number than it needs to be. So the only thing here that gets squared is 2.5, so 2.5 got squared, then times 3.14, then times the 2, and that's where I'm getting the blue number here. Now, of course, that's only covered up the top and the bottom. That's the 2 circles. So now let's take care of the weird curvy part, which would be a rectangle label. So you've got 2, whoops, sorry, let me clear that. 2 times 3.14 times the 2.5, and of course times 4. And that's where I got this 62.8. And now when you add it to the top and the bottom, you've covered up the entire cylinder, and that's where I get the 102.05 square inches. All right? Now for this one, it's pretty much the exact same thing. In my picture, I've given you the diameter, so you need to cut it in half for the radius to be a 7.5 when you plug it in. Now I'm still going to use my calculator here to show you guys that if we've got 2 times pi times the radius squared, 7.5 the radius, that's what gets squared first. Now show me times 3.14 times 2. Okay, so that's where I get my 353.25. Now in my work, I want to point out here that the 2 times pi pops up a lot. So a lot of students just go ahead and recognize that 2 times pi is 6.28. If you kind of memorize that, then in your calculator, once you do the 7.5 and you square it, then you can just do times this 6.28, and that takes care of the top and the bottom. Now this is the weird curvy part. Again, that's the length and the width of the rectangular face, the 2 pi r h. And when you crunch these numbers, we get 565.2. When you add the weird curvy part to the top and the bottom, you get a 918.45 square centimeters for the entire surface area of this cylinder. So friendly reminder, all we're trying to do here is cover up a cylinder. You've got a pi r squared, which is a circle. Since there's 2 circles, that's the 2. And then this is the part where you're covering up the weird curvy face that when you peel the label off, it's actually a rectangle. And now you know how to cover up a cylinder, and that concludes this video. Thank you.